Guys, I hope you're fine. In this video, we are going to explore Dijkstra's algorithm. Now, Dijkstra's algorithm is used for finding the shortest distance from a source node to all other nodes in the graph. We are going to be dealing with a weighted directed graph. The example graph is going to look like this. So we have 5 vertices labeled 0, 1, 2, 3, 4. It is a weighted graph because the edges carry weight on them, and it is also directed because there is direction present on the edges. So there is an edge going from vertex 0 to 2. This is not bidirectional. I can only go from this edge from 0 to 2. We will be keeping track of two things: unexplored nodes, so I have all the 5 nodes unexplored, and a distance. I'll be assigning or initializing the distance as infinity for all nodes. We will start with a source node. The node 0, represented in red, is the source node. We are going to, in our list of unexplored nodes, we are going to label it as red, which means I have visited it. And we are going to look at all the nodes which I can visit from this node. The nodes that I can visit from this node are node 1 and 2. The distance from source to source is 0, so I will update the distance for vertex 0 as 0, for vertex 1 as 2, and for vertex 2 as 4. Now what we are going to do is we are going to look at a node in this distance vector that we have, or distance array that we have. We're going to look for a node which has the smallest distance and is unexplored. So the smallest distance is 0, but I have already explored node number 0. The next smallest is 2, which is the distance for node 1. Node 1 has not been visited so far, so we are going to go ahead and explore node 1. I'm now going to look at all the vertices which are directly reachable from node 1. Node 1, using node 1 I can reach node 2. So in our distance vector, I will go ahead and update the distance to reach 1, which is 2, and the distance to reach 2. So at index 3, I will go ahead and use 3. 2 plus 1, 3. Then I can also go ahead and use or reach the vertex labeled 3 at a cost of 2 plus 4, 6. I can also go ahead and I can reach the vertex labeled 4 at a cost of 7. That is the distance to reach vertex 1, which is 2, plus the edge going from 1 to 4, which is carrying a distance 5, which is 7. Now let's look at a node which has not been visited so far and carries the least distance. That would be node number 2. So in the next slide, or in this diagram, we are going to visit node number 2. From node number 2, I can go back to node number 1. If I go back to node number 1, I can reach 2 in a distance of 3. When I go back, it is 8. Now that means for node labeled 1, I will be traveling back with a distance of 8. Now I already have a smaller distance there, so I would not update it. I can also reach 4, node number 4, with a total distance of 6. 3 plus 3, 6. So I will go ahead and I will update it. Earlier I had 7, so I will update it with 6 now. I can reach vertex labeled 3 in a distance of 5. Earlier I also had 5, so I had 6 earlier rather, so I will update it with 5. And we are now going to look for the smallest distance for a node which has not been explored so far. That comes out to be node number 3. So this is where we come down. I can go ahead and I can reach node number 4 from node number 3 in a total distance of, now I can reach node 3 with a cost of 5 plus 1, 6, which is already there. 6 is already there, so no update there. And now I will go ahead, and the only node that I'm left with is node number 4 with a distance of 6. So we'll go ahead and explore this node. And if I'm going to look at the path followed to reach all nodes from the source node 0, it is going to look like this. In this video, we explored what a Dijkstra's algorithm is and how a sample Dijkstra algorithm works on a sample graph. The next video in this series, we will look at the coding portion or the implementation part. Be safe, guys. Thank you. I hope you enjoyed this video.